I want you to work this Coulomb's law problem. And let's just quickly review Coulomb's law because we just did it last time. We've got, if you have separated charge, that is you have a big basket of electrons or a surplus of electrons and a big basket of surplus protons somehow, you concentrate them all at a point. Those are called point charges. How much, what do we observe? What's the force? We observe a force between them. We call that the electric force. The most very, very powerful force. It's the force that keeps ordinary matter together, and it's the force that makes chemistry happen and all that sort of thing. So for 2 point charges like this, we have Coulomb's law, which was said to be, let me put a vector hat on this, the electric force is the electric constant here, which is 9 times 10 to the 9 newtons of force for every meter squared over Coulomb squared here, times the charge on one object times the charge on the other, divided by the distance between them squared. So if I had these two forces, or two charges right here, I'd plug in their charges in coulombs. I divide it by the distance between them squared, make sure that's in meters, and then multiply by the electric constant, and you would have the force. Okay, and these are the four. If you rub a balloon on your head and stick it to the wall, or you're pulling your socks out of the dryer and they're all sticky or whatever, this is the force that's involved in that. So it's static electric force. So here's the problem. Use Coulomb's law. Let's say I've got Q1 is right here, and I'm going to give it a positive 2 microcoulomb charge. And then here's Q2 right here. Q2 is at x equals 2 meters away, and it has negative 1 microcoulombs. And then another 2 meters away at x equals 4 meters, I'm going to put a third charge that's 3 microcoulombs. And here's what I want you to figure out. What is the electric force that 1 applies to 3? So here's charge 1. I want to know what force does this charge apply to this charge? So I'm looking for the force on charge 3. And then I want to know what force does 2 apply to 3. And then I want to know what is the net electric force on Q3 due to these two charges. So you have to basically add these two forces together. So if you're watching this online right now, pause the video and try to do it yourself. But since you're here watching, we'll just do it right now. Okay. So let's solve it. Well, let's figure out what the force of 1 on 3 is. Well, it's K times Q1 times Q2, Q3, I'm sorry, Q3 over R squared. That's kind of the generic term. Now let's put in the values. 9 times 10 to the 9 Newton meter squared per Coulomb squared. Now I'm going to multiply by Q1. Q1 is 2 microcoulombs. Now what does micro mean? Times 10 to the negative 6. Don't forget to multiply that in. And then what is Q3? That's 3 microcoulombs as well. And then we're going to divide that. What's the distance between Q1 and Q3? 1, 2, 3, 4 meters. So I'm going to put 4 meters, and it's got to be in meters, and I'm going to square it. Now I'll get, so this is part A. So the F of 1 on 3 is equal to, so let me plug that into my calculator here. I've got 9, and then my calculator has an EE button. 9 times 10 to the 9 times, and then I'm going to go 2, and then micro means EE button negative 6. 2 times 10 to the negative 6 times 3. Hit the EE button, negative 6 again, equals. And that's 5.4 times 10 to the negative 2, but then you have to divide by 4 times 4, which is 16. So I'm just going to divide that by 16. And I get 3.375 times 10 to the negative 3 newtons. So just a little bit of, not much force. Now for part B, the force of 2 on 3. Oh, now let's get direction though. Let's get direction. Now look, Q1 is positively charged. And Q3 is positively charged. So what are they going to do? What are 1 and 3 going to do? They're going to repel each other. So what is the direction of the force on 3? It's to the right. Okay, now, what's the force of 2 on 3? Well, it's 9 times 10 to the 9 Newton meters squared per Coulomb squared times Q2, which is negative 1 microcoulomb, times Q3, which is 3 microcoulombs. Divide that by the distance between them squared. That's 2 meters squared. So let's figure out what that is. So this is the force of 2 on 3. And so 9 times 10 to the 9 times negative 1 times 10 to the negative 6 times 3 times 10 to the negative 6 equals, and then this is divide by 4. 2 squared is 4. Divide by 4. And I get negative 6.75 times 10 to the negative 3 newtons. What does this negative mean, though? Well, remember I said that's negative r hat, which means it's an attractive force. But that makes sense. It's a negative charge. It's a positive charge. So they attract each other, right? So if they're attracting each other, what direction is the force on Q3? To the left. So instead of doing that, I'm going to say, on the screen here, let me put a box around this because that's the answer. I'm just going to say, instead of calling it negative, the force of 2 on 3, I'm going to say that it's 6.75 times 10 to the negative 3 newtons to the left. Now you can put a negative in there if you know that that positive means to the right, negative means to the left. That I would accept that as an answer to. Okay, now part C. The net force, the net electrical force is what you get when you sum all the forces acting on Q3. Well, here's Q3, and I've got you got F1 on 3, and you got F2 on 3. Notice, do you see that they're in opposite directions? So when I add them together, I got to keep that in mind. So I'm going to go F1 on 3, and I'm going to say that's 3.375 times 10 to the negative 3 newtons. But look at F2 on 3. It's to the left. So what am I going to do? I'm going to subtract it. Okay? That's what that negative sign meant over here, is that this is it's to the left. Whenever you're dealing with pluses or minuses and you have a vector quantity, that's what you got. So, so when I add those together, I get negative I'll just call it 3.3. Negative 3.3 times 10 to the negative 3 newtons. What does that negative mean? Or you can say 3.3 times 10 to the negative 3 newtons to the left. Yeah, you can put, well, no, just say to the left or to the right. The r hat, I almost regret showing that to you, but you would actually call this negative I hat. I hat means in the x direction. Negative I hat means in the negative x direction. Positive I hat means the positive right direction. We haven't really talked about that in here that much, so don't worry about it too much. But the point here is, what I want you to do when you're looking at what the electric force is, draw a little picture of it like I did right here, showing the direction of the force, and then you'll know whether to add or subtract them to get the total magnitude of the final force. Right? Does that make sense? Okay. Question?
How'd you get to -3?
Huh?
How'd you get to -3?
Well, you can see that this value here is smaller than this value. In other words, the force to the left is greater than the force to the right. So when you add the force...
No, I'm saying the exponent -3.
Oh, right up here? It just came out to be that way when I did the arithmetic.
I don't understand how.
Well,
So 9 times 10 to the...
well, remember, what does that micro mean? Times 10 to the -6. Times 10 to the -6. So that, yeah, that's where it's coming from. If you just went 9 times 10 to the 9 times 2 times 3, you're going to have an answer that's a million times bigger than what I got. And so you just need to adjust that. Any other questions? Okay. That is